All right, I think we're good to get started. So good afternoon. By way of introduction, my name is Shawn Bice. I basically work on the non-relational assets at Amazon, so that's DynamoDB, Redis, Memcache, Neptune, and some other projects. But before that, really grew up on relational systems. I'm sort of here to talk to us about sort of all these different database choices that we have. So for the time we have today, we're going to kind of break this talk into three parts. Part one, we'll just spend a little bit of time on, sort of this question like, gosh, why are there so many different database tools available today? Why is that? So we'll share a little bit of history and context and try to offer a frame on how to sort of reason choosing the right tool for the right job. The second part of this talk, we'll do a demo. So Joe's going to join us. Joe's over there on the side of the wall now. But Joe will join us and do build an application using different database systems. So that's a lot of fun. And then the third part, we'll just kind of summarize. And then at the end of the talk, I'm going to try to get us done about 5 minutes early if I can. There's a bunch of people from the database group here, so I'll ask those guys all to come up. And then anybody that has questions, you can just pick somebody. This way we can kind of get to more people quicker. Okay, so with that, over the page is a number of sort of cloud applications that I'm going to assume most of us have used one of these apps at some point. But if you think about sort of, if you've reserved a lift, if you've watched Netflix, if you've been on, you've made a flight reservation through Expedia, the reality is that you've interacted with some really, really powerful web application. And a lot of people, if you kind of pause here and think about it and said, hey, well, if there were 1 million people every day about to reserve a lift, do we know what time everybody's willing to do that? Imagine the challenge of trying to figure out, I don't know what time every user is going to want to reserve a car, or do you know what time everybody's going to want to watch a movie, and what movie are they going to watch? And just imagine the engineering challenges that are related to that. Or if it were Expedia and you're trying to reserve a hotel room or a flight, how do you ensure that you're giving the best experience, the best, you're providing the best rate based on demand? Like, how do you do that in a way that's consistent, it's accurate, your users have a very good experience, et cetera? But over the page are examples of applications that offer these very personalized, very unique experiences in a very global fashion. And one of the questions that I always get is like, well, what is really behind these apps? And I like to start with a little bit of historical context. Now, for those of us that have been in the database industry, this is not a complete, exhaustive history of databases, but it's kind of like the cliff notes to some things that I think are interesting. It's sort of, why are applications different today? What is different about applications? And I like to start with this. If you think about in the 80s, there was really 3 predominant databases that many, if not most all, applications were built against. With DB2 and Oracle and SQL Server. And, in that era, most applications were dealing with order of thousands of users. The geography was typically local. It was usually on a LAN. And that's kind of how things worked. Then, if you think about the 90s, basically, the internet comes along. And for those of us that remember those days, most people had no idea what this internet thing was really about. But MySQL and Postgres, like this notion of open source database engines started to become real. But one of the challenges is in the 90s is hardware was still very expensive, like really expensive. Why? Because in the 80s, like when somebody was buying a database, a SQL server or an Oracle database, you were typically buying some of the most expensive storage that was known, some of the most expensive processing power. It usually had a scale-up story. It's like big dollars. And if you and I were going to build a website in the 90s, we couldn't afford to buy anything like that. But this notion of open source was moving along at a good pace. People were building websites. in the 90s. And then in the era we're sort of in now, things have changed dramatically. People today are building cloud applications, not websites. In these cloud applications, what's really happening behind the scenes is hardware is now dirt cheap, storage is dirt cheap. I can get to a database system in order of seconds or minutes if I'm a developer. Why? Because it's a fully managed API. There's open source choices all over the place. And frankly, these cloud applications are doing so much that they're driving different requirements, different database requirements. And that begs the question, well, what's really going on with the characteristics of a cloud application? And sort of over the page, this is just trying to illustrate some of these things. So when you look at applications in the cloud, I don't come across too many customers that are talking about a globally distributed cloud application that are using a single database mechanism underneath or behind the scenes. Like that, I don't see that at all. Instead, what you see is you hear people talking about users in order of millions. It could be, I don't know, we might have 1,000 users today. We could have 1 million users tomorrow. We could have 10 million users. We really don't know. But that's the reality of a cloud app, is you could be dealing with 10,000 users or 10 million users in an instant. And you have to be able to scale to that size in a hurry, because if you're always having to step back, think about it. If you had to design for that, prepay for that, and you don't get 10 million users, the economics just don't make any sense. So you have to now look at different pieces of your environment that you want to use. What pieces of software are you using? What technologies are you picking to solve what particular use case in an application? The data volume is only getting bigger. Speed is only needing to go faster. So back 5, 10 years ago, most people talked about speed order of seconds. That's like super slow in internet terms. If I have millions of users and I want to Snapchat a message to a friend, I want that to happen instantly. So speed today on these cloud apps are all about milliseconds and microseconds. That's just the speed. Like the global scale is only bigger, the size of data is only bigger, but things need to run even faster. And another interesting thing here is scale is not just up, it's very much distributed and out. And probably the most important thing here on the very bottom is developers now can get to pretty much most, if not all, database tools through this notion of a fully managed API. What's interesting about that, I don't have to think about replication, I don't have to think about HA. If I want to have a global table in DynamoDB, within just a few clicks, I can do that. Now I have a multi-master environment. Why would I use DynamoDB? Well, key value is really interesting to me. Why is key value interesting to me? Well, frankly, what I need in the app is a shopping cart. I need super high throughput, endless scale, and predictable performance. Key value could be great for that. I may be doing something else in my application where referential integrity matters. I might be transacting something that must be consistent. And if that's the case, I'll use a relational model for maybe the ordering part of my app. And if I wanted to give a personalized recommendation, so imagine you're shopping for lodging, and what if the system knew you and your friends and could say, instead of here's what others said about a destination you're going to, here's what your friends said about a network. How might I do that? Well, I'd probably use a graph system that's designed to do that very quickly. And that's just sort of a real fast lap at the characteristics of these cloud apps that are very different, that are driving different database tools. That's why a number of these things exist. But very easily, this can be overwhelming in itself. So if you think about it, in the 80s, there's generally 3 databases that most apps are being built against. Any idea how many database systems are being tracked today? Anybody? So for someone who's thinking right now, something like 342, you're probably right. There's over 300 database systems that are tracked today in DB engines. And DB engines is an interesting tool. It's not about deployments and installations. It's about what developers are talking about. There's over 300 choices today. And why is that? Like, what is driving that? I'd argue that the characteristics of these cloud applications are what's in fact driving it. But how do you reason through 300 different choices? What is the one word that you could sort of start with? And the one that I found to be most meaningful is purpose. I would always remind myself of, having grown up through an era of seeing an application where you literally would only have 2 or 3 choices of a database to build it against. Very easily, you could overburden an aspect of that database quickly. Not today, because today you've got choices around relational, key value, document, in-memory, search. There's these different choices that you have. And I've always found that the developers that have really sort of started to wrap their head around this, one of the first things they say is, what is the purpose of the tool? What's the tool trying to solve? Is it super fast throughput, low latency, endless scale? Great. If that's the case, then I can start looking at key value tools. Is it referential integrity that I need because I need absolute consistency? Well, then I'd go look at Aurora and RDS. Is it a graph? Am I trying to get after a connected? Am I trying to do personalized recommendations? What's the tool that has a purpose for that? Graph. But I see a lot of developers leading with this notion of purpose. It's really having a point of view of what is the purpose of the tool. And the spirit of that is making sure you don't pick a tool that you overburden, then you have to rewrite your app. An analogy we like to use is this vehicle analogy. And it's an interesting one. In the lower left is a pickup truck. It's a great utility. It can pull a trailer. I can put a little bit of cargo in it. I can throw some people in it. That's its purpose. It's a utility vehicle, and it does it extremely well. If you and I were going to try to build an airport, and we needed to move thousands of tons of dirt, we could use that pickup truck. We'd probably overburden it. It'd take us a long time to move thousands of tons of dirt. Or we could use an earth mover in that lower right corner whose purpose is to move tons of dirt efficiently. And then if we were going to start up a company and we were going to deliver groceries in neighborhoods, for example, if we were reasoning through different vehicles, we'd end up on that delivery truck in the upper right because that door and that driver almost standing up is by design. Its purpose is to get through very tight streets, park in very small spots, make it very easy for a driver to get in and out of that vehicle, to go all the way to the back, grab a box, drop it off on somebody's porch, get back in and do it again, right? And then finally, if we were going to move cargo across the country, we'd probably first look at an 18-wheeler because its purpose is that. It might have refrigeration in it, I may not, but the point is that each of these vehicles has a purpose. And I think when you kind of use that analogy over databases, I've always found people usually find the right answer, just always reminding themselves, what is the purpose of the tool, and how can that tool support a use case inside of my application? And that's very different from 30 years ago, where it was generally one tool, a application, and trying to make every use case in that application work against the one tool that you had. So that's the difference in the world we have today is we have a lot of choices. And let me give you an example, a real example of building a cloud application against a tool whose purpose didn't even take into account cloud scale. And that is Amazon. That's like pointing a finger at ourselves. So when Amazon first started, it was built against a set of database systems whose purpose was not Amazon scale. And when you sort of overburden a tool, in this case, Amazon selling and having customers literally around the world, imagine the scale dynamics with it. If I try to build that against a system that's usually dealing with users in order of thousands or tens of thousands, the system gets stressed out. If I'm used to having performance of seconds, and I actually truly need millisecond performance, you can overburden a database, and when you do, that happens. You end up on CNN, and you talk about, sporadic issues and outages. It's no good. And in this particular case, we ended up taking a step back to build our own technology, which was this Dynamo Paper. And this Dynamo effort and the people that were involved with it across the top of the page, they really kind of took a step back and said, man, what are the characteristics of a cloud application? What's different? And and they got a point of view of that. Okay, now if we were going to build a database or a technology whose purpose is that type of scale, what would it look like? And that's the genesis or the origination of this Dynamo Paper, which has led to one of the tools we have, DynamoDB. Not the only tool we have, but just one. Now, when you think of Dynamo's purpose, it's all about super fast throughput. You could, endless scale, millisecond latency, predictable millisecond latency. What does this look like from a customer's point of view? It looks like this. So if you remember the World Series from a couple years ago, the Chicago Cubs won the World Series, which was a big deal for Cubs fans because I don't think that had happened. I think it's like over 100 years since they had won. But here's the kicker. It's not that. Imagine if you're Snap. You don't know who's going to win the World Series. You don't know what inning it's going to be. You don't know what time it's going to be. You don't know what day it's going to be. But at some point, it's going to happen. And when it happens, what do most people on Snap do when an event like that happens? That happens to be the first baseman caught the ball as a final out. They win the World Series. What do most people do? Pull out their phone, take a selfie, take a picture, text a buddy, send a message. Instantly, people all over the world could be doing this. That's what it looks like on the baseball field. This is what it looks like to us. So, yeah, it is a wow. So when you look at some of these numbers, could you imagine if that first baseman caught that ball and the system couldn't handle that load? And everybody's like, oh my gosh, I got to send a message, oh, timeout, errors. Like that's using a system that has the wrong purpose. In the sense of Dynamo, that's just another day for Dynamo. And it's not that it's a magic trick. It's that key values purpose is really about really fast ingest, high throughput, low latency to accommodate that kind of scenario. That's a great example of using a tool for its purpose, and that's what it looks like in our operations center. I'll give you another example. Prime Day. When you're doing Prime Day, you really don't know when people are going to surge shop. You're not really sure which items people are going to go crazy for. But when Prime Day goes, you're talking for a system like Dynamo. The last Prime Day, I believe, was the largest or the biggest global shopping event in Amazon's history. And that was another day for Dynamo. And it's primarily because its purpose is to deal with this kind of load, 12.9 million requests per second, at any point in the day. It's not, it's a thing to take quite seriously, but I think it really illustrates the point of, boy, if you think about a shopping cart and throughput and low latency and predictable performance, key value is interesting. It can support things like this. Then if you think of Expedia, and I'll kind of let you read around the page there, if anybody's ever traveled with Expedia, and there's a lot of people traveling, they're using Expedia for hotel rooms and lodging and flights. And if you look at these numbers that they work with, it's incredible scale, and it's very diverse, and you're trying to give very unique experiences to customers. And then, from a product perspective, if you shop for lodging, there's this notion of real-time contextual pricing. Now, one of the things from an engineering perspective that's important here is referential integrity and consistency, and the computation that goes along with that. What tool would you use for those set of words that I just brought up? Certainly not key value, right? In that particular case, I'd go straight to a relational system, Aurora or RDS. And that's just a mental model to just think of using these different tools for the right jobs in an app. And then even from I know you'll hear key value systems with giant scale like we just saw, but relational systems scale as well. I mean, they also scale. In this particular case is a view of Expedia with Aurora. 1 billion rows is a lot of rows. The cool thing is with Aurora is that you get referential integrity, you get transactions, you get strong consistency, and you get this kind of performance, 4,000 plus writes a second, less than a millisecond of insert latency. It's awesome. And then I'd kind of give us this view right here. When you think about a cheat sheet or a tear sheet, These are kind of the 6 categories that I hear from developers all the time. And sort of the way to think about this cheat sheet is, instead of thinking of the application and, oh my gosh, there's over 300 database choices, that could be overwhelming for anybody. But I think what you'll find is that, if you kind of take a step back and think, hey, what is the purpose for the tool? Or you think of use cases within an application. When you come across use cases where referential integrity and consistency matters, it's probably going to point you to a relational. When you come across use cases like a shopping cart where it's low latency, endless scale, super fast throughput, you're probably going to find yourself working with a key value system. If it turns out that you need a lot of document flexibility in a schemaless system, you're going to find yourself looking at documents. If it's creating navigation between relationships and it's about connected data use cases like a personalized shopping experience, you're probably going to use Graph because that's what its purpose is for. If you think of EA Sports and online gaming, do you really know how many people are going to be gaming at literally at the same time? You can guess, but I'll tell you, online gaming and leaderboards matters a whole bunch, and in-memory systems matter a bunch, and this is why Redis is so popular. It's an awesome, awesome tool for that kind of use case. And then finally, if you think about doing log analytics and having tons of log files with literally everything a user has done in a site, then using something like, first I want to index and search that. Using something like Elasticsearch is a great tool. So I'd give you that as a tear sheet, and I think at this point I'd ask Joe to come up to show us a real quick demo of using different database tools behind a given app. Joe?
All right, thank you, Shawn. So not too long ago, I walked into Shawn's office, and it's one of those situations where you walk into your boss's office and he has something up on the screen, and you don't want to ask the question, but the next thing you hear coming out of your mouth is, Shawn, why is there a graphing calculator on your screen, and why are you buying this from Amazon? Thankfully, it wasn't for Shawn, it was for his high school son. But then we started to kind of sidebar on that conversation, and we started talking about, hey, back when the last day I bought a TI-89 calculator, how would we have built an app? Turns out it was a LAMP stack. And then we kind of started a little bit more looking at Amazon's website, and we said, hey, look at all the different use cases on this website. What database do you think powers each of these different experiences behind Amazon? And it turns out there's a lot of different experiences there. And Shawn said, well, why don't you just go build that application? So that's what I did for us today. I built an application, and I tried to fit the use cases that we had for a typical shopping application to the specific database so that I'd use the right tool for the job. So we built a web app, and we're going to use DynamoDB, and we're going to use Lambda, some Amazon Elasticsearch service, and Amazon Neptune. We're going to stitch this together. All right, so in the theme of graphing calculators, I made us a web application to sell graphing calculators. So the first experience that we look at when we build a web application like this is a product catalog. The first thing I want to be able to display to people is the product that I have. That's pretty part and parcel for this type of app. Now, when I get started at this, I have a bunch of different choices, but what was really important to me was a flexible schema, something that was serverless, something I didn't have to fool around with, because I knew, building an application early, I'm going to be kind of messing around with stuff, and I want it to be really fast. So I chose DynamoDB, and let me show you just quickly, how easy it is to get started with creating a new DynamoDB table. Right, so I'll go into the, 1 second, please. Of course. All right, back in action. All right, so we go into the DynamoDB console. I just want to create a table, and the table is pretty simple. We'll call it, live SF, demo, and product ID for my key. And we'll go ahead and create that. And now I can start adding information to my table, and I can start iterating on what I want my data architecture to look like for my store. But once I have my products, the next thing that I want to be able to do is I want to provide customers with a really great search experience. I think we all can attest that if we go to a website that has a poor search experience, the bar is so high now for search that that will force us to leave a site. I think we all want a very convenient search experience. So I look at the tools around me, and that's my scenario. I want to do search. So I look at the different assets, and could build it on top of DynamoDB, but it's going to be work. I could build it on a couple other databases, but it's going to be work. I'm not really interested in doing a lot of work. I'm more interested in building this application fast and using the right tool for the job. So I decided to use Elasticsearch Service because that is the best tool for the job. It's really good at full text processing. But now I kind of have an interesting situation. I have my product table in DynamoDB, but I also have my search index in a different database. How do I reconcile keeping those two things in sync? Because I don't want this to be a manual process, and I want to make this really slick. So DynamoDB has a really nice feature called DynamoDB Streams. And what Streams does, and I'll enable it for my table that I just created, is every time we insert or modify a data in this table, it'll write it to a DynamoDB stream. And then I can use something called a trigger to be able to process events to that stream with a Lambda function. So I've already created a Lambda function ahead of time, and I want to have a batch size of 1. So every time one item is written to this table, I process it. And let me go ahead and create that, and let me show you what this Lambda function looks like. So this Lambda function is pretty slick. It's just a little bit of code that looks for if the event name is insert or if the event name is modify, and then it'll write it to my index. So every time something is updated in that table or inserted, it writes it to my Elasticsearch index. So now I have a really convenient way to be able to keep those two things in sync, and I don't have to do a lot of work. Now we want to extrapolate a little bit on this further. We know the calculator business is going to be kind of challenging, and we're probably going to need global scale. So it turns out there's a lot of talent for calculators in selling calculators in Ireland, so I want to be able to scale my application to another continent. How do I go about doing that? Because now I want to keep my product catalog in sync between two continents, not just between two databases, but now in between two continents. And again, that's a lot of work to do if I have to do it on myself. One of the really nice features that DynamoDB launched at reInvent last year was a feature called Global Tables. What Global Tables allows me to do is replicate my data with multi-master capabilities between multiple different contents and multiple different data centers. So let's add on this particular scenario. We'll go to Global Tables, and we'll add another region. Okay, so we'll add Ireland, and we'll go ahead and continue. Right, so now I have my table that's replicated in Oregon and in Ireland. So anytime I write data in any of those tables, it gets replicated, which is going to be pretty handy. So let's go ahead and now test our entire scenario. All right. Is anybody in here from Ireland? Not a single person? Has anybody gone on vacation to Ireland in the last 10 years? Anybody want to tell me a name of a town that they went to? Cork. Okay, I think I have, multiple Cork. It must be the place to be. All right, so we procured some calculators in Ireland. We'll call them the Emerald 44s. And instead of Sligo, we'll use Cork. All right. So we're going to insert this data now into our product catalog in Dublin, right? So what we should expect this to do now is write it into that table in DynamoDB in Dublin. It's going to get replicated across the states to our table in Oregon. We're going to get it written to that queue, that DynamoDB stream. The Lambda function is going to pick that up, write it to our Elasticsearch index, and then customers should be able to search for that product immediately in the States. So let's trace that path of that data. All right, so I've already cooked the turkey, so to speak, ahead of time. And let's go to that table in Ireland. Right, and we'll go to products, items, and let's see, where's my... So Bing 44 gets written across. We go to our table in Oregon. Right, and we'll go to our products table, we'll go to items, do a refresh. And there's Bing 44 right there. So we go back to our website, and then we can search for that particular item. We'll come back to that in a second. And then there's Bing 44. So we can replicate that across to multiple different regions. Now, one of the things about selling calculators is this is probably a pretty highly competitive industry, and just having calculators probably isn't going to be enough. There's probably a lot of price pressure. So one of the things I can do to differentiate my experience is have a really good recommendation engine. And not just a recommendation engine that just says, hey, for everybody that's ever shopped on the site, they've also purchased these particular items. I want to provide that that's really contextually appropriate to people that I know and friends that I know, because I'm actually much more likely to buy stuff that my friends know about than just random people off the street. So a really good database to be able to match that use case is Amazon Neptune. And I've gone ahead and I've created a social graph, or a graph of maybe what my world would have looked like back when I was purchasing a calculator when I was in high school. And for people that aren't familiar with graphs, the circles are called vertexes and the lines are edges. And what the vertexes are, you can kind of think of those as nouns. They're like people or they're items, like a calculator or a class. And the edges are kind of like verbs. They define the relationships between them. And the way that graph databases work is you can query these types of graphs or these types of relationships very efficiently and very intuitively. Sure, you could do this on another database, but you're going to be really getting into a lot of trouble. You're going to get into a lot of trouble with, it wasn't purpose-built for that. It's going to be really slow, and then you're going to have to be writing a lot of code that's going to be probably pretty complicated. So in this scenario, we're going to say, like, hey, for me, I want to know who all my friends are. So we're going to go from one vertex, knowing an edge, to another vertex. Then we want to know what those items that those people bought. Right? So I've fired up Gremlin console ahead of time, and this is a way that you can query a graph database. And let me walk you through this query really quick. So we started off with the vertex v1, that's me, and we're going to go out from the edge. We're going to say, hey, what people do I know? And then we're going to order those by weight increasingly. So how much do I like those people? And then from those people, we're going to go out again from that vertex, figure out what they bought, and then what are the names of those products. So it's kind of like walking through a map. It's actually a very intuitive way to query a database. And then this is going to reply and tell me that these are the products that my friends have bought, which is great, but to be able to use it in my application, I actually need the GUID. I actually need the GUID because that's how I'm going to tie it back to my product table, and then I'm off to the races. All right. So if we go back to our application, so now it's great. We have DynamoDB set up. We have Elasticsearch set up for search, and we also have Neptune set up for graph. Now, a few other scenarios that we might think about with this particular application is saying, I need to know how the business is running. I need to know the quality of service of my website. And what people tend to want to do there is do a lot of web analytics, or they want to do a lot of log processing, because I'm using Apache, so I can grab those logs, and I might want to instrument my application. So what would be a really good tool for that particular job? Again, it comes back to Elasticsearch. And that lets me do a lot of different log analytics. Now, one of the things I really like about Elasticsearch, and this for me is a delighter, I really like it, is it comes with an endpoint for Kibana installed already. If folks don't know what Kibana is, it's a way to visualize log analytics on top of Elasticsearch. I'm a very visual guy, so it's great to be able to query it, but I want to be able to create a dashboard so I can see how my website works. So I've created this ahead of time, and it's just kind of an example of, hey, for this website, I can see how many bytes are coming in and out. I can see error codes by different types of errors over time. I can see all the different request codes. I can see which pages are being hit. I can see where the traffic is coming from. It becomes a really useful tool for that particular job. All right, so we kind of keep building on this. We can say, hey, if we didn't log into my website, but maybe I want to use Redis or DynamoDB to do session state, right? Sometimes that's ephemeral data. We can use an in-memory data store. For my orders table and my inventory, perhaps I want to use a relational system because I want to make sure when I credit the orders table and I debit the inventory that either all happens at one time or not. I don't want to get in a position where I oversell or don't have product to sell to customers when I actually do. So this is just an example of going through just kind of a simple scenario of using a different database for using a specific database for the use case, and then choosing the best tool for that particular job. So we went through, we used a couple different databases, flexible product catalog, great search experience. We used Neptune to do a really quick but very powerful recommendation engine. So appreciate the time. Thank you.
All right, the final stretch. So that's, if we kind of build on what you saw there, kind of show you, there are many. In fact, I was just in the session before this looking at a McDonald's picture, and it's interesting to see these cloud applications draw architectures like this. I might be using, in this particular case, EC2 with Dynamo and Redshift, along with EMR. These are all different tools being used for different aspects of an app. And I personally always think of a use case inside of an application, and then for that particular use case, let it be a shopping cart, or an ordering system. The next thing I'd ask is, what are the right tools for that use case? When I hear referential integrity, it's always leading me to Aurora or RDS. If I hear about high throughput, low latency, endless scale, I think of key value. If I hear connected data like a personalized recommendation, I start thinking of Neptune. And you kind of see these things over the page. For example, if I show you another one, in this case, somebody's using Lambda. They're using Dynamo, they're using Elasticsearch. If I show you a third one, that pattern is everywhere. None of these pictures are of an application using a single anything. You might find that on a developer's desktop, but when you go from an on-premise app with thousands of users connected on a LAN, and you transition through building a website to building a full-blown web application with globally distributed users. Your data size is only getting bigger. Your requirement from your customers to only be more personalized and faster. These are the kind of architecture diagrams that you're going to get after. Is it overwhelming to think about 300 different choices? Absolutely. Is there a way to kind of reason through that? I think so. And I think it always starts with asking that question. What is the purpose for the tool? What is the right tool for the job? What is the job? The job typically would start with, what's the use case in the application? What's the best tool for it? Why would you do that? So that you don't end up in a situation where you pick one thing, and as you start to grow your application, you have that notorious World Series moment, and the system stops running. In my experience, I see folks overburden that utility pickup truck instantly. Why? Why does that typically happen? It could be somebody started with a very small app underneath their desktop or on their laptop, kind of got it going, wasn't really thinking about 12 or 13 or 14 million users and petabytes of data, and next thing you know, you reach that point. On the other hand, the folks that I see start architectures like this, and they really are looking at the different use cases within an application, they usually have the best success as it relates to really big scale, speed, performance, personalization. All of that sort of explains why we have the set of building blocks we do. And over the page are the different data building blocks that we provide. So you'll often hear us talk about 90% of the time, we listen to our customers and make sure we're delivering what they need. You'll hear us say things like we spend 10% of our time listening and innovating on behalf of our customers. But guess what? I hear developers like you say the same thing to me. Like, I'm building an application for my customers too. I listen to my customers and I want to move fast and I want to innovate. I need to give them what they need, and I also need to listen to them and innovate on their behalf. I mean, we're sort of both in this together. And I would not stand here and say, there's nothing on this page that says, hey, there's one thing, there's one database, and it does everything. That's kind of like me saying, well, there's one vehicle. It's an earth mover. It's a pickup truck, and it's a this and that. That's why these different things exist. Oftentimes, it has to do with scale and performance and efficiency. So you have a number of tools to pick from, and then when we add more tools to this, just remember the way we reason it is we're always asking, what's the use case? What is the developer asking for? Do we have it in a tool today? If not, do we need to provide a new tool? But this is not a random selection of items in any stretch of the imagination. And the intent is, if you think of all those apps that are running on Amazon in some sense, in those architectural pictures that I was showing you, it's a very common pattern, very common practice for people to sort of use a combination of different choices that you might see over the page. The interesting thing for this is who really is one of the most important resources in any organization. And I think what's really happening is developers are more empowered now than I've ever seen before. Turns out, 10, 15, 20 years ago, the way it really worked is an architectural committee would decide the platform you were going to build your app on. End of story. It was a corporate standard. That's the way it's going to go down. Things are different these days. I meet more business and technical leaders that say to me, hey, if I go tell my developers, like, look, this is how it's going to go down, you get to choose these 3 things, I'm not going to have talent. Like, they're not going to work on the projects that I want them to work on. Why? Because they're looking at these different tools. A developer now can go straight to a console, just like Joe did, and you have a fully managed API. You don't have to think about replication and patching things or backing up and restoring. Those things are handled for you. So the real phenomena here is in today's age, when you think about that cloud application that you're building and you start with that, what's the use case and what are the requirements and what's the tool, a developer can ideate on that API very quickly and very cost effectively. That's one of the big changes that you're seeing in the landscape today. The next thing I hear from a lot of leaders is this. Like, if you've heard Werner talk about you build it, you run it. I've literally been in rooms with business leaders, technical leaders, and major corporations, and I ask them, like, how do you keep up with the 300 different choices that are out there? And many of them say, hey, look, we tell our developers, you build it, you run it. That's the deal. Because we don't want to stifle innovation. If we stifle innovation, how are we going to outcompete who we're competing with? That's the last thing we need to do is slow ourselves down. We actually have to run faster. So the you build it, you run it mantra, I hear that across many industry segments. But again, this is why that notion of fully managed APIs matters a ton. When we think about these different building blocks, we like to think of them as I'm describing them to you. Like, we really do think about, hey, the last thing you want is 4 tools to have encryption and rest and the 5th one not to. That's not helpful. So when we go through and think about each tool that we're adding to it, we always are putting ourselves in your shoes, ensuring that we have as much consistency as we possibly can. We want to make the developer experience as easy as we possibly can. Can we be better in certain places? You bet. We absolutely can, and we will every day try to get better with it. But that notion of a fully managed API really, really matters a ton. Why? It really sort of boils down to this. you hear about DevOps, people use that term a lot. We try to think of it as like we want to handle the ops so that you can handle the dev. So with that, I'm going to go ahead and stop. I'm going to ask the database folks that are here from the team to come up front. And then if you have any questions, grab any one of us. And thank you for your time today. I really appreciate it. Real quick. Hey, one thing I want to let you all know. Rick Houlihan is doing a session that builds on this. So if you enjoyed some of this content, he's over in room 2005, and he's going to go, 2005, he's going to go into all the details, or I'm sorry, 2002 of the details that build on top of this. So thank you. It's the very